At first glance, it looks like another breathtaking image of deep space. Bright stars sparkle across the foreground while countless distant galaxies fill the background, stretching farther than the eye can follow. But this isn't simply another beautiful astronomical photograph. It marks the beginning of a new chapter in humanity's exploration of the universe. For the first time, the Vera Rubin Observatory has begun revealing the sky through one of the most advanced astronomical cameras ever constructed. What makes this observatory remarkable isn't just the sharpness of its images. It is the enormous amount of the sky it can observe, again and again, over many years. Instead of taking isolated snapshots, Rubin is designed to watch the universe change. Its digital camera is unlike anything that has come before. With more than 3 billion pixels in a single image, it captures extraordinary detail across an enormous field of view. Every exposure contains information about millions of stars, galaxies, and other celestial objects. Viewing one full-resolution image at its original size would require an enormous collection of high-resolution displays placed side by side. Yet the camera itself is only part of the story. The real breakthrough is repetition. Night after night, the observatory will scan the southern sky, recording the same regions over and over again. Tiny changes that would normally go unnoticed suddenly become impossible to miss. A star brightens. A galaxy hosts a distant supernova. An asteroid quietly moves across the darkness. A completely new object appears where nothing existed before. This continuous survey transforms astronomy from a collection of still photographs into a living record of the changing universe. The observatory's first images already demonstrated this incredible capability. One remarkable field contains millions of galaxies spread across an enormous region of space. Some are elegant spiral galaxies with bright blue arms where new stars continue forming. Others are massive elliptical systems filled mostly with older stars that have long since ended their active periods of star birth. Among these distant galaxies lie stars belonging to our own Milky Way. Although they appear close together in the image, the objects exist across an astonishing range of distances. Nearby stars share the same frame with galaxies located hundreds of millions, or even billions, of light-years beyond them. It is a reminder that every astronomical image is also a journey through time. The farther away an object is, the longer its light has traveled before reaching Earth. Rubin also captured evidence that the universe is constantly evolving. Some galaxies appear calm and symmetrical. Others show clear signs of gravitational interactions, where neighboring galaxies slowly pull each other apart over millions of years. Long streams of stars stretch outward while distorted shapes reveal ancient cosmic collisions still unfolding today. These dramatic events remind us that galaxies are not permanent structures. They grow, merge, and change throughout cosmic history. But while Rubin explored the distant universe, it also noticed something much closer to home. Tiny streaks crossed several images. They weren't camera defects or processing errors. They were asteroids moving through our own solar system. Instead of ignoring these objects, Rubin's computer systems automatically recognize their motion, measure their paths, and report potential discoveries to astronomers. This ability makes the observatory valuable not only for studying distant galaxies but also for improving our understanding of the countless rocky objects orbiting the Sun. Every clear night has the potential to reveal thousands of previously unknown objects. And this is only the beginning. These first observations represent the opening moments of a scientific mission planned to continue for an entire decade. Each night will add another chapter to an ever-growing record of the changing sky. The universe has always been in motion. Now, for the first time, we have a telescope built to watch that motion unfold in extraordinary detail. As impressive as Rubin Observatory's first images are, they represent only the beginning of a much larger mission. Unlike most observatories, Rubin wasn't designed to focus on just one galaxy or one distant nebula. Its true purpose is to observe the entire southern sky again and again for the next 10 years. That simple idea changes everything. For generations, astronomers captured moments in time. A single image could reveal incredible detail, but it was still only a snapshot. Rubin transforms those snapshots into a continuous record, allowing scientists to watch the universe evolve instead of simply photographing it. Every few nights, the telescope will return to the same regions of the sky. Its computers will compare each new image with earlier observations, examining billions of pixels in seconds. Even the smallest difference becomes instantly visible. A star suddenly grows brighter. A distant supernova appears where nothing existed before. An asteroid shifts across the background. A variable star changes its brightness. Or perhaps an entirely new cosmic event emerges without warning. Instead of waiting years to notice these changes, astronomers can detect them almost immediately. This technique turns the sky into an ongoing scientific investigation. The amount of information collected is almost impossible to imagine. Every night, Rubin will generate tens of terabytes of raw data. Over its planned survey, the observatory will build one of the largest astronomical databases ever created. Managing that information is a challenge of its own. Powerful computers and advanced software will automatically process every image, identify new objects, calculate their positions, and alert observatories around the world whenever something unusual appears. The telescope doesn't simply collect data. It helps scientists decide where to look next. Rubin is also giving astronomers an extraordinary view of our own Milky Way. Its wide-field images reveal vast clouds of gas and dust where new stars are still forming today. These stellar nurseries stretch across enormous distances, connecting bright young stars with the material from which future generations of stars will eventually emerge. Instead of studying only a small section of these regions, Rubin captures the larger environment surrounding them. That broader perspective helps researchers understand how entire stellar neighborhoods grow and change over time. The observatory also plays another important role much closer to Earth. Every night, it searches for moving objects throughout the solar system. Many of these are ordinary asteroids, but some could become valuable targets for future exploration. Others may pass relatively close to Earth, making early detection extremely important. By repeatedly scanning the sky, Rubin will dramatically expand our knowledge of these small worlds. Perhaps the greatest achievement of the observatory isn't any single discovery. It's the opportunity to discover the unexpected. Throughout history, many of astronomy's biggest breakthroughs came from finding something nobody was looking for. A strange explosion. An unusual object. A phenomenon that challenged everything scientists believed. Because Rubin watches such a large portion of the sky so often, it has an excellent chance of detecting events that previous telescopes might never have seen. That possibility excites astronomers more than anything else. The universe is constantly changing. Stars are born. Stars explode. Galaxies collide. Black holes grow. Asteroids travel silently through the darkness. For the first time, one observatory will watch these events unfold on an unprecedented scale. Rubin Observatory is not replacing famous telescopes like Hubble or the James Webb Space Telescope. Instead, they work together. While Hubble and Webb examine individual objects in extraordinary detail, Rubin continuously surveys the sky, identifying the discoveries that deserve closer investigation. Together, they create a far more complete picture of the universe than any single telescope could achieve alone. These first images are only the opening chapter. Over the coming decade, Rubin will record billions of galaxies, discover millions of new solar system objects, detect countless changing stars, and build the most detailed time-lapse record of the night sky ever attempted. And perhaps, hidden somewhere inside that enormous stream of data, will be a discovery no one has yet imagined. Because every time humanity builds a more powerful window to the cosmos, the universe finds a new way to surprise us.